Hey there, Portable for Parents. Mr. McCauley here. I'm just going to go over a review of Chapter 1 in the math textbook. This is all from Chapter 1. It's for both grade 5s and grade 6s. And the general topic is talking about patterns in numbers. Okay, so let's first of all take a look at some simple patterns and how do you figure out which number comes next? What I do right away is I try to look at the difference and I try to figure out some kind of rule based on that. Between the 2 and the 5, I'm going to write a 3 up here because there's a difference of 3. And I notice there's another 3. I notice another 3. So right away I can see that this is adding 3 each time. So 11, then I add 3 would make it 14, etc., etc. And I can keep going and going and going to the end. So this particular pattern has what's called a common difference. And that's when the difference between the terms and numbers is the same. So the terms, these are all the terms. Terms and numbers are they kind of mean the same thing. The difference between is common. It's the same, and that's what a common difference is. Let's take a look at this next one. Again, use the same strategy each time. The evidence usually is kind of in the middle. So we go to 1. This time I have a 2, so something different's going on. Then I have a 4. Then I have a 1. Then I have a 2. Then I have a 4. So I kind of notice that it's kind of, the difference thing this time is 1, 2, 4, 1, 2, 4, and I'm going to imagine it goes on and on. This time the difference, it's not common. I don't have 1 all the time, but it does repeat. And that's the pattern of add 1, add 2, add 4. Add 1, add 2, add 4. So here I would add 1, then I would add 2, and then I would add 4, 22. So sometimes a pattern might have a common difference. Sometimes it might be a repeating difference. Let's go down here and take a look at this one. This one is a 1, and then I have a 2, so it's not a common difference. Let's keep going. Then I've got a 3. Okay, then I've got a 4, then I've got a 5, so I see it's increasing or growing. So this one is kind of a bit of a growing pattern in that the difference between the different terms or the numbers grows each time. So this one's going to be a 6, and that gives me 22. This one's going to be 7, and that's going to be 29. So in a growing pattern, or the difference or growing difference, the difference between the terms and numbers increases. But you know what? Sometimes they can also shrink. It could be a shrinking difference. So watch out for that. I wonder if there'd be a question on that on the test where the difference actually shrinks. I wonder. Okay, let's go on to page 2. Page 2, we're going to talk about working with tables. Boys and girls, parents, tables are your friend. Tables are really a way of organizing information. They're one of the most basic pattern things in math. Now, let's keep going. In this question, it's draw the fourth design. So another strategy is to draw. Drawing is an excellent strategy, and it's excellent to a point. Now, it's asking me to draw the next one. I don't mind drawing one, but if I have to draw they're asking me for what's the 10th in the series. I don't want to spend time doing 4, 5, 6. Drawing is good to a point. When you got to do a lot of drawing or the numbers get really high, drawing is too slow. Okay. Now, when I'm looking at the way a pattern grows with blocks or shapes, I kind of take a look at how much it's increasing by, how many blocks it's increasing, but more importantly, I kind of look at what's happening. So for example, let's look at what's happening from between the first one and the second one. To get to the first one and the second one, I've got to add 1 on the side of this box, and I add 1 on the side of this box, so I'm adding this one and this one, and then I've got 2 more on the bottom. So plus 2 down here. And then I keep going. So I add 1 here, and then 2 and 2. So this pattern altogether, you're adding 1 here to each side, and then 2 to, let's call this the tail. So if I'm drawing this again, instead of 1, 2, 3, 4, 5, I'm going to add 1 and 1. This time I'll have 7 across here. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4. I'm going to add 2 more to that, and I'm going to add, let's see, 4 on the tail plus 2 more is 6. So I go in the middle, 1, 2, 3, 4, 5, 6. Okay, so there's what it would look like. Instead of 5 across the top, I have 7, and instead of a tail of 4, now I have a tail of 6. Okay, so it's kind of good to take a look at what actually is happening. Where are the pieces being added? And that'll really help you to figure out what the pattern is. And again, drawing can be limited. So how would you show the 8th design? I wouldn't be drawing them all. That's when Mr. Table comes in. Okay, the first one has 1 block. The second one has 5 blocks. So we're taking 1 and we're adding 4. 1 and 1 and 2, that's 4. Then this next one has 9 blocks, and then 13 blocks, and adding on the spot here, 17 blocks, 21 blocks, 25 blocks, 29 blocks. I hope that's right. I'm adding 4 each time. Common difference in this is 4. So the point here is, hey, drawing is good if you're drawing 1 or 2, but if you got to do a lot of them, go to the table right away. Okay. Now let's fill in this table again for a recipe. Now, for one serving, if I'm just making one group of, let's pretend they're cookies, it's 2 cups of flour, 250 mils of water, and a half cup of butter. If I'm doing 2, then I'm going to double it. So 2 times 2 is 4. 2 times 250 makes it 500 mils. And we haven't done fractions yet, but if you have a half of something and a half of something, that gives you a whole. That gives you whole 1 cup, etc., etc. And I'm going to, you can go down and fill this in 2, 4, 6, 8, 10, and this is 500, 750, 1,000 mils, which is also 1 liter, and then 1,250 mils, and then 1 cup and a half, 2 cups, 2.5 cups. That's what that table would be like. This is just practice for filling out a table. Okay, it was late when I did this thing. You may have noticed these tables come from the other side. You don't have to do them, so don't worry about that. So this is mostly a grade 5 concept because it was in the grade 5 textbook, not so much in the grade 6 textbook. But it's looking for patterns in problems. And here's a question. Let's say you had to add up all these numbers. You could go through and do 8 additions as you go along, but there's a way to look for patterns. That we did this 4 or 5 times, so I'm hoping that this is going to be second nature to the students by now. If it's not, we'll have some reteaching to do. But one way to solve this is to take a look at the smallest number and pair it off with the largest number. So 10 plus 80 will give me a value of 90. But then 20 plus 70 also gives me 90. And 30, so there's another 90. And 30 plus 60 gives me another 90. And 40 plus 50 gives me another 90. So I have my 90, and I can multiply that by 4 to give me a quick 360. So when you have a pattern like this, what you can kind of do, when a regular series of number like this, you can take the big guy, add it to the little guy, figure out how much that is, and then figure out how many pairs there are, and you can do some multiplication or addition to get your value. The one thing watch out for, if you've got an even number, everything will pair up really nicely. But if I added 90 here, then that 50 doesn't have a pair in the middle, so watch out for that. Once in a while there'll be a question where you've got pairs, except for the guy in the middle. He's kind of a lone ranger. Here's another one here. How many cans? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can pair the 1 and the 10. So 1 and the 10 gives me 11. And how many pairs are there? There are 10 numbers. To find how many pairs, you take that numbers of pairs and you cut it in half. So that means 5 pairs. So 11 is the total for the pairs. There's 5 pairs, so that will give me a total of 55. There definitely will be at least one question, if not more, on this kind of solving of patterns and numbers. Last part, this is all for grade 6s, grade 5 parents and kids. You guys don't have to listen, but hey, you want to listen, you go right ahead. This is the beginning, really, of algebra now. And it's talking about variables and expressions. This is brand new for the grade 6s. And when I take it up in class, I can tell by looking at them that it is a brand new concept for them. I won't have too many questions on the test about this, but I will have at least 1, maybe 2 at the most. So what is a variable? A variable is a number that changes and is often represented by a symbol like X or N. For example, let's say a variable could be the number of days that I walk to school. Well, it could be 1 day, 20 days, 30 days, it'll change. An expression, is, I'm going to call it a math story, and it's made up of symbols and variables. Let's take one about Wyatt. the one and only goalie in our classroom. Wyatt stops 20 shots per game. So one thing I know is that Wyatt is stopping 20 shots per game, right? We know that. The problem is, write an expression to calculate how many shots Wyatt saves during the season. We don't know how many games he's going to play. So let's use the letter S, and that really means how many shots altogether. And then let's say that the shots is 20 per game, but I don't know how many games there are. So I'm going to use the variable G to represent the game. Okay, so the shots altogether is 20 times the number of games he has. This number of games is kind of a variable. It'll change. If it's only one game, then you're okay because it'll be 20. If it's 10 games, it's 200, and et cetera, et cetera. So this is how you solve a single variable expression. Usually we're looking for some total. We have some kind of constant, and we multiply that by the variable which will change. We don't know what that is. We have to write this. Writing an expression like this is one of the things the kids will have to do. And I'll tell a story similar to the one above. Here's the really tough stuff. The really tough stuff. You ready? We'll give it a shot. I'm not sure I'm going to have a question on the test. It is in the curriculum in the textbook, but here we go. This is when you have two variables. Now, when you have a single variable, like the number of games, you can solve that because you just plug in the number of games and then you'll figure out what your total is. But what if you don't have that? Okay? If you don't have that, you have to work to make a double variable into a single variable. What's going on there? I'll explain. So let's take a look at the question. Mr. M eats 6 pieces of fruit every day. Mr. M only eats applies. No, that should be apples and oranges, sorry. Writing expression to describe Mr. M's eating habits. So he eats 6 fruits a day, and they are apples plus oranges. Okay? That's not a 0, that's an orange. So here's a math story that's talking about apples plus oranges. How many apples a day and how many oranges a day? That I don't know because I've got two variables. It doesn't give me any information. Okay? But what we're going to get some more information so that we can get rid of one of the variables, and then we'll be able to solve this. This is really tough stuff because it's brand new for the students, but let's give it a shot. Mr. M eats twice as many apples than oranges. So he eats lots of apples and he eats half as many oranges, or there's twice as many apples than oranges. So if I write another expression, the number of apples that he eats equals the number of oranges twice, because he eats twice as many apples as oranges. So the amount of apples is going to be the orange plus the orange. For example, let's just make up a number. If I ate 10 apples, then I would only eat 5 oranges and 5 oranges. So now comes the super tough part where we shove these two together to solve for this. Because we know that A equals something, what I'm going to do is I'm going to throw the A in here, and I'll be left with just oranges. So let's try that. 6 equals apples plus oranges. I also know that A equals oranges plus oranges. So what I'm going to do is, for this A, I'm going to insert the oranges plus oranges from over here. And let's see what I get. 6 equals orange plus orange plus orange. So that's 3 oranges. So 6 equals 3 oranges. What possibly could orange be? Well, orange has to be 2, because 3 times 2 will equal 6. So the orange equals 2. If orange equals 2, then the apples has to equal 4 because of up here, right? Orange equals 2, then a apple equals 4. Now, if you're a high school math student, this is something that comes second nature. But this is the first time the sixes are looking at this, and I'm going to try to make it as easy as possible. I don't know if I'm going to do a double variable question on the test, because if we do some more review, I'll be able to test on it. But if I don't, it might be just something to put away for a little while. And that is it. Sorry for the long-winded review, but those are the main concepts that will be tested on the test, which is on Thursday. Good luck, everybody, and I'll talk to you later.